Okay, what I'm going to do in this vodcast is walk you through the process of doing the Food Calorimetry Lab, which means we're going to measure how many calories per gram there are in 3 different food items. We're going to use the same basic coffee cup calorimeter that we did in the previous lab, but this one will be a little bit different. Instead of using a coffee cup, we're going to use a tin can. So what you're going to have is a tin can, and then in the top of the can, where you have that tab, you're going to stick a pencil through here and suspend that tab using the ring stand so the tin can is above the ground. Yeah, or above the table. Of course it's going to be above the ground. In the can you'll have your water, like we did with the previous lab, and you'll have a thermometer so you can read the initial temperature and the final temperature. Below the tin can, what you're going to do is you're going to have a food item. And let's just assume that this thing here is a marshmallow. You'll put some sort of paper clip through it so you can suspend it above the ring stand and above the table. And then what you're going to do is you're going to light that food item on fire. The idea being all of the potential energy stored up in that food item is going to be released during the combustion. So the heat and fire that is released when that food item is undergoing the chemical reaction is going to heat up the water in our calorimeter. So if you remember from our lab with the metal, we took a piece of metal, heated it up, put it in the water heated up, and then we knew all of the heat that was absorbed by the water had to come from the metal. Well, it's the same basic idea here. When this food item burns, it's releasing its heat energy. We're going to measure that heat energy by measuring how much heat is absorbed by the water. So we'll know the mass of the water, the initial temperature of the water, and the final temperature of the water. That way, what we can do is measure Q for the water, which would be the same Q as the Q for the food item. And then what we're going to do is measure how much of the food item actually burned in terms of grams, which would be the mass. So we're going to have joules per gram, but we're going to convert joules to calories because calories is the energy unit that we use for food. So what we should be able to calculate is how many calories per gram are in this food item. Now, just a little disclaimer here. As with the metal in the water calorimetry lab that we did, this lab has a lot of room for error. In other words, the food is undergoing combustion, so there's a certain level of oxidation taking place. So this change in mass is not exactly the most accurate measurement we'll make all year. And a lot of heat is also lost to the atmosphere that doesn't go into the water. So our measurement of calories is going to be an estimate at best. However, you'll get decent results by doing the experiment this way. And again, it's the idea of heat being transferred from the food item to the water that we can measure. All right, let's take a look at the data that you're going to collect. So you're going to set up a data table, and you will do that, and you're going to put it all on a Google Doc, or not a Google Doc, but a Google spreadsheet. So you're going to collect your data, and you're going to do 3 food items. So you're going to set up your data table to account for all 3 food items. You're going to want the mass of just the water in the cup, so you know you're going to have to get rid of that mass of the cup, and you should know how to do that already. And you'll want that in grams. You'll want the initial temperature of the water before you do anything, and you'll get that in degrees Celsius. So after you set everything up and the water has had a chance to settle down in terms of temperature, take its temperature, you want the initial mass of the food in grams, because again, we want that change in mass when the whole lab is done. And then you want your final temperature of the water in the cup, also in degrees Celsius. And you'll want the highest temperature. So as your temperature of water is rising, what you're going to do is continue to collect data until it reaches its highest point. You'll know it reaches its highest point when the temperature starts to go down, but then you'll record that highest temperature. When you're done with that, you'll find the final mass of the food item in grams, and you're going to want to use a weighing dish to transport your food so you don't lose any of it in case some of it turns to charcoal or ash. Then you're going to do the calculations for this lab, and you're going to have 3 food items, and you're going to have 5 calculations, so you'll have a total of 15 calculations. And again, you're going to set this up on your data table, and you're going to show, and you're going to type, unfortunately, these calculations and show how you calculated these 5 calculations for each of the 3 food items. So we're going to calculate delta T for the water, so you know we'll go final temperature minus initial temperature. You're going to calculate delta M for the food, so final mass minus initial mass. You'll calculate Q for the water, so Q will be equal to our mass of water times C, which is 4.18 for the water, and then we will have our final temperature minus our initial temperature for the water. You're going to convert your Q in joules to calories, and we'll have the conversion for that. And then you're going to calculate calories per gram for each of the 3 food items. So you should have that calculation for all 3 food items. Okay, let's just do a sample set of calculations here. And these numbers I just kind of made up off the top of my head, so I'm not entirely sure we'll even get reasonable results here. So anyway, we're going to calculate Q for the water. So we're going to take 225 grams of the water times 4.18, which is our specific heat for water, and that looks like a 9 again. And then we're going to take our final temperature minus our initial temperature, and let's do the math there. We should get 5,643, so 5,643 joules. What we're going to do is convert our joules to calories, so we're going to take 5,643 joules. You can use either one of those. I guess I'll just use the first one. So 1 joule is 0.239 calories. So let's do that. And we will get 1,348 calories. Okay, for our food item, what we're going to do is find how much food burned. So we're going to take 1.9 minus 2.4, and that's going to give us negative 0.5. Now we don't really care if it's negative or positive, so I'm just going to say the difference is 0.5 grams. So we're going to take our calories over our grams. Let's do that math. And we're going to get 2,697 calories per gram. What you're going to do here, and we'll talk about why in class, you're going to take your decimal point and move it over 3 places. So whatever answer you get, move the decimal over 3 places to the left. So that's basically, if you rounded, 3 calories per gram, which is pretty darn close to either a carbohydrate or a protein. So anyway, you'll do these calculations for all 3 of your food samples, and then you need to report your data. So let's talk about what you're going to do to hand in and get credit for this lab. You and your lab partner will produce a Google Doc containing the following: your data table, which is completely labeled, so label everything, the data you're collecting, what you're collecting in the unit. I should say what the value is in the unit. You're going to have your 5 calculations for each of the 3 food items, and you're going to type out those calculations, and I know that can be a little cumbersome. You're going to type a conclusion which includes an explanation of your results, and it should contain 3 things. Did your data match what it should be? In other words, did you find that the carbohydrates and proteins are 4 calories per gram and the fats are 5 calories per gram? The second thing is why or why not. In other words, you're commenting on how the lab went. The third thing you would do is indicate how you would change this lab to get better results. And I gave you some hints at the beginning of this lab. So do those things in a Google Doc and a Google spreadsheet. and then you're going to hand those in. And then again, you're going to label your, and this is actually a Google spreadsheet. However, you could do the spreadsheet and then insert it into a Google Doc. But anyway, label it, your period, put an underscore, last name, first name of you and your lab partners, underscore, and then food chemistry. This is very important. At this point of the year, I still have people who are not doing this, and again, if you don't do this, I'm not going to grade it, and then I'm not going to grade it until you do it the right way. So please format it correctly. I know that sounds picky, but I get a lot of these, and it really does help with the organization. So good luck, and don't hesitate to ask questions in class.